prepare the document, and you type this address in a navigator, and you download the document. I hope. It's that one. Okay, so just connect the address. And when you connect, normally you can download the document. Yes, upload. Technology. By mail.
Và cái link kia thì ai đấy nó bảo là
Okay, we try doesn't connect. Try another way. Okay. Okay, 2 minutes. So you can find this document at the following address: PLO, okay, point passo, point esti.fr / torus.html. And you can download it by right-clicking on the, or by clicking on the link. I hope.
Not found. Click me. Not found.
Okay, okay. It's okay? No. It's right click. Okay, right click. It's VI. I'm not familiar with VI. Okay, it should work now. If you refresh. it every way you want. You've got to open it. So, for example, you can in Torus, for example, there is an old version. You can delete it in Torus. This one is no more usable. So you open it, and it should appear like this. It's the file Torus.js, and we make step by step. I will explain you on the process. Okay. So for the moment you download, you open it, and then we've got to start the database. So you open a file manager and you go to document Torus, and normally you have those files. Here you right click on the middle of the screen and choose open terminal here. Okay, right click and open terminal here. You have a terminal like that. And then we are going to start the database. The database is not started by default. So to start the database, you type /. Does anyone has a problem with retrieving the file? Yes. Okay.
Yes.
Okay. So it's because I made a mistake, so we must reload the page. And then terminal to start the database. So, so first, we start the database.
Okay, this one, right?
Typing start shard.sh. Start shard.sh. You can use tab to complete. Then you strike and you don't close the terminal ever. So it starts the database, I hope. I will explain how the database is constructed because I have sharded the data. So now the database should start, and you can show the command.
The command line.
Yes. It's /start.
J'aime bien le plan tools.stat.
Okay, so you've started once and you type this just once. Then you open a new tab. Donc, file, open tab. Okay, to have here in background the database started, and then here we are going to connect to the server to type the requests. Okay, so it's no, okay. Once you have started the database, okay, so you should have the terminal like that, and then you click on File and Open tab. Okay, so you have a second tab with a fresh terminal. Okay, File, Open tab. Here, I hope we are able to connect to the server. To connect to the server, you type Mongo __ for 27030. And then you strike enter, and you should see something like that. You are connected to the main router, which is MongoOS. You should have that, and you're connected to the database. To remind you the structure, so okay, here we are connected to the server to a default databases which name is test, and we won't use this. We are going to. I explain you the architecture I put in place for this exercise. So here I created on a single computer a sharded database. Okay, so there are 3 shards, 3 servers who will share the data. Okay, the data will be distributed in 3 servers. Okay, so here we have 3 sharding servers. Upon the sharding server, there is a config server which we don't mind. It's a database administration issue, we don't mind. And there is a router. The router is the main server who centralizes the data and the requests. This router is the one in which we are connected to. The 27030. Okay, this one. The shards, the number, I'm going to say to you later after, they are 27021, 27022, and 27023. There are 3 sharding servers. Okay? So, we are now currently connected to the main server. If you check if you check the Torus.js, we are connected, we made the first step, connected to the router. Now we are going to log on to the GeoRef database, which centralizes our data. So you type here, use GeoRef, and strike enter. And now we are connected to database GeoRef. I hope. Be sure of the spelling of GeoRef, because if you type a database that doesn't exist, it will work. because it can't connect to a non-existent database. And when you put information, it will create the database. So to connect to my existing database, you be aware of the spelling of georef. Okay? So here we are connected to georef. Then the next step is some information, but I won't detail that. It's, if you want to try this at home. It's statistical information about database, collections, etc. I can show you if I take db.stat, it prints statistics about my database. So here you can see the sharding server. The first one is the 27021. It's the first sharding server who owns a database georef, who owns 16 collections, which collect 740 rows of data, etc. So you have on the sharding server the first one, the second one, and the third one below. Okay? Is the distributed server, okay? And then you have the statistics of the main database, the global data. Now we are going to insert fresh data. It's data which Dominique knew. It's data about the Spitzberg glacier.
Spitzberg, field observation of plants.
Yes.
On the Spitzberg area, it's close to the North Pole.
So it's data about georeferenced observation of plants. Okay? So we are going to create a collection to store this data. To create the collection, we don't have to, there is no special command to create a collection. We are going to prepare the fact that we will create a distributed collection. Okay? So to create a distributed collection, you type, the following command on the GS file, which is you are going to shard a collection which name is, it's a technical name, not Plantus, it's a technical name from Dominique. You are going to...
On n'a pas la ligne de commande là dans le...
Torus. Okay, but you should take it, so I will...
Voilà, date.
Okay, well, I got an error because it exists. Oui, parce que tout est clair dans l'ancien. Okay, so it's okay, I have got an error because on my PC the collection already exists, so you shouldn't have the same display. So you should have a display with OK. Oui, yes. The command is that one. Okay, it's is sh.shard collection georef And this document, the second parameter, is the criteria of the sharding. So when we are going to put data in the database, we are going to index it by a system function on the ID. It's admin stuff. It's a default behavior. We are going to shard on the ID criteria. You don't have to bother. It's an administrative.
Shard collection.
Yeah. Yeah. Okay. Ah. Okay. Okay. Yes. Okay, it's weird. I mean, you type it once, it's okay, and the second time, it means that it's already created, so it won't create anymore. Okay? It's okay for? Yeah? Okay, it's okay. You create, okay, one. Create it well. Okay? So, here, with a simple command, we have created a new collection, and when we are going to inject data, the data will be distributed between the shared server. Okay? So, this is what we are going to do. We are going to inject data. So, to inject data, we are going to make it step by step. So first, we are creating an index on the attribute that will store the geo information. So you type db.counters, which is the collection, .create index on the attribute geometry, and we create the index named to this sphere. Okay, that command is to allow geoquery to the data. After, we are going to insert our first data in the database. So, you've got to make a copy-paste. So it will be more simple. Okay, to insert data. Donc, one data. You see the result. Normally, it's right result, number inserted 1. C'est quoi? Tu l'as? Il ne faut pas trop taper. Tu l'as déjà vu où? So now there is one data, we can access it doing db.planttools. You can use tab to automatic completion. .find. Find without criteria, and you will see it will retrieve the data. Well, it's for me, I got already all the data, so you will see one data. The design of the database is my choice. Is not quite a good design. You've got, if you look the data, you have an ID property, you've got a geometry property, and you've got a properties property. Okay. Yes. So you shouldn't type all the commands. They are all in Torus.js. You can make a copy and paste. So, shell collection. Okay, create text. Okay. And then so if you check your data, you will see that one data is an ID, a geometry somewhere. Yeah, a geometry. And properties. In the properties, you've got all the information of the, what is the term, of the observation. You've got the topology, commentary, and you've got flowers and plants, and the number of plants observed. Occurrence.
Okay. Number of plants from things. Okay.
And it's the architecture of our data. Each observation is those four fields. Okay. So here we have. Yeah. Tell me.
So how decide if you're connected to
To the route 27 or 30, always.
We have 3 servers.
Yes, but I will explain it just after. So we have one data. You have another way to insert data. It's the same method. It's the next. Here, I create a variable data. It's a new observation, and then I save this variable data in the database. So it made the same, basically the same thing. I will save the data, but in a different way, using the save method. So you can do copy paste too, and it will insert another data. Okay? So here we have in our collection 2 data. And then, because there are 300 observations, we are going to make mass insertion. So to make mass insertion, on the next command, we load a file which, in which there are all the observations, and we inject all the observations in one command. So you load, with this command, you load all the observations in the database. It will make true, okay, as it worked. We are going to check, so it's the next command. We are going to count how many data we have in our database. Well, me, I have injected twice, so I have 600. So you should have 300. Okay? So in our server, we have 300 observations. Now we are going to check how it has been sharded. We are going to verify if our distribution of the data has worked on the server. So to do that, you are going to open a new tab. File, open tab. And we are connecting to one of the server shards, not on the router, on the server shard. So to do that, you have to take Mongo security report 27.0, and for example, the first one is 021. Okay? Here, you are connected to the first shard server. Okay? And then, we are going to use GeoRef to connect to the correct database. And here we are going to check how many data we have in the collection plantools. So we are going to do db.plantools.count. No. You should have 100. No? Well, you shouldn't have 300. You should have a part. Voilà. So we put 300 data on the database, and it distributed on all the shard servers with only one command. It's very simple. We declared 3 shard servers. We told that a collection will be sharded. We insert the data, and the data is sharded is distributed in the 3 servers. So in the first one, you have, if you want to check, you connect to the second one, which is 27.022. You do the same. You will see you got a subpart of the 300 data. Okay. So the sharding is very, very simple. And then you close the tab, not the terminal. You close the tab and you click on the terminal which is connected to the server, MongoOS. Okay, you come back to the server. It's with the prompt MongoOS. Okay, and then we are doing some queries. So here you have 2 queries to check. For example, we retrieve one command, one plantools, Okay? And you have the description of one plant. So here is how the data is structured. You have the ID, the type, the geometry, it's the location where the observation has been made. Okay, so you have the longitude and the latitude. And the properties of the observation. Okay, so you have a commentary with an empty field, you have a code for topology, and you have all the plants observed for one data. Okay? So now we are going to make another request. So here, if I want to see only the property of all the plant tools. So here I put plant tools.find null because I don't have a selection criteria, and then null it works, but I don't like it. I prefer empty document, but you can keep it null. And then I say I want to see only the property field. Okay? And you will see it shows the property field only and the system ID. Always, when you are making a query, by default, we will review the system ID. Always. So if you don't want the system ID and only the property, you have to tell, I don't want the system ID. So you have to put underscore ID 0 to say, I don't want you to display the system ID. And you see that you only have the property. So you have to add on the projection criteria underscore ID double dot 0 to say I don't want the ID, I just want the property. Okay, it's a very simple find query which interrogates all the data and which review the property. Okay, then, for example, to check our data, I want to count all the data where there are no commentaries. I think there is a mistake. The commentary, it's not commentary. I was tired when I put this request. Everywhere you have commentary, you have to tell the commentary is a field of properties. So you have to put properties dot commentaire. I'm so sorry. Okay, because commentaire is not a field of the document; it's a field of a sub-document. So here, I will count how many observations with you have to put double quote around the field. And here you have a certain number of observations where the comments located in the property field are not empty. Okay? So you got a certain number of correct commented observations. Okay? If you want to check all the observations that don't have commentaries, you do equal equal. Okay. And you should have a number of correct of empty command tree. Okay. Or it's yes.
The sum is 300.
Well, for me, because I have more data. Ah ouais, okay. It's the file you downloaded. What did you download? You download the file with. You went to my site? Okay. Well, it's not important.
Sur le drive que tu nous envoies,
So here you have to change this by put that request here. There is 100 that you don't need it. No, in the test. It was the test. When you are connected, you are connected to the database test. You have to connect to the database before. Okay.
Partager,
Ah,
mais je sais plus aux envers.
No problem. Okay, it's okay for everybody? No? Yes? So we are going to use paging here. For example, I retrieve the 10 first results. Okay, so the function dot limit will retrieve we have to put the double quote when there is a, excuse me, and I will retrieve the 10 first results of the query. You have to put you can correct it, you can make corrections on my file. Okay, donc here there are the 10 first coordinates retrieved by the database. And fortunately, it retrieved the same results if you must sort by ID, I think. if you launch so the data is distributed. So we can ask if we launch the request several times, they may not have been the same result order. You know, if the third server responds quick, faster, maybe you have the data of the third server first. But I think he should do a sort by ID before showing the results. So the results, if we launch the rocket the query many times, the results will be in the same order at any time. Okay? Okay, now if you want to make a second paging, you have the next request to say skip the 10 first and retrieve the 10 following. Okay? Here I say don't look at the 10 first and give me the 10 following results. Okay? So the next request so the next request, what we want to do is to find the commenters for and the number of croûte noire observation for all the observation which has the selecting criteria croûte noire greater than 21. We are going to find all the data. For all the data, we are going to check the properties and the specified properties croûte noire amount, and we are going to select only the croûte noire which are greater than 21. Okay, it's the selection criteria. And then, when we will have all the data, we are going to display only the number of croûte noire and the commentary associated. Okay? And maybe the commentary field will be empty. Huh? Ah, it's properties. Dot commentary. So if I put it, you see, for example, the first one, we have the commentary replace table, and the number of croûte noire is 22. The second one, we have as commentary value external stable, and the number of croûte noire is, I don't know, is 24. Okay, etc., etc. Okay, if you want to see if I can sort by number of observation on croûte noire. So croûte properties dot croûte noire and I want to sort it ascending, to make a sort ascending. Then you see all my observations are sorted ascending on the group noir property, and the lowest starts to 22. Okay, that because I asked all the group noir greater than 21. So the lowest is starts with 22. Okay? And you see that the job is almost not done. There are many commentaries empty. Yes. So here I put you with a mistake again and again. Here you have to put not commentaire but properties dot commentaire with double. And here put double view. We have an example of an update request. What does this update request? It updates the plantose, which is situated here. So I put longitude, latitude, and I will retrieve all the observation at this point. And then I will update only one field, which is named, it's the $set operator, which updates one field, and it's the field properties dot countries, and I put a classic Torus. Okay, so here I make the update, and he told me he has found one corresponding data, and he has modified it. Okay, it's an update example. So here, if I check this plantose, normally you have the commentaire set to hello Torus. It's here, hello. Okay? So it's an update example. Okay, we have an example here of updating, renaming a field. Usually when you are updating data, we think we are updating value of data. Okay? Here we can modify also the description of the data. Okay, with rename, we are changing the property name, the key name, not the value name, the value. Okay? Huh? What? And multi.true, yes. Multi.true is because the update by default will update one field. The first one it encounters. If you want to update all the data that match the criteria, you have to add multi .true to say make a multi-update to all the data. Okay? Because by default it updates only one data. Okay? Here I've got an example of an update to increase the value. I omit some requests because of the hour. I will show you important requests. So here I've got Well, you should have only one. Huh? Me, I have two because I made two times the insertion of the data. So you have when I find the observation at the following coordinates, I find one observation. You have one observation. No. No, two? None? Oh, one. One, yeah. You have one. And the value for Juncus bigumis is 1. No? 0. Okay. So, if you check the other request, what will I do? I say, for this observation, update the Juncus bigumis number and make an addition and less 1. Okay? I say this one you add minus 1. So it's to make a difference. Okay? And for the property mousse, you add 2. You understand or not? I update two fields with the plus operator, and for the first one I make plus minus 1, so it makes minus 1, and for the second I make plus 2. Okay? Okay, and if I show you the results, here I have 2 and it made minus 1 and there are only 1 left. Okay? Which one? The dollar ink? You all have an error doing that? Okay, I don't understand. You want the data?
I change the coordinate.
Oh, yeah. Sorry. Well, we pass. Huh? You see, it worked once, and so it will work every time. Okay, so I I will accelerate. I will pass some queries to show you the geoqueries because it's already new. So here you can find distinct file from the distinct command tree. It will retrieve, because some data may have the same value, so it retrieves the distinct value for one field. So here I tell, give me all the different command trees version for the data with no redundancy. The distinct, then to make this one is interesting, to make an average of the value moose. What? Okay. It's always the demo group. No, it's not. See, you really not. Okay, I will try without no, I passe. Ouais, oui, il va y avoir un second. 1, 2, 3. Ah, il manque une. Ok. Okay, here I make an average of moose. So, well, it's not, well, it's useless because as I wrote it, I have an average by ID, and the average by ID is the same because you have an average for one observation, and the average of one observation is the value of the observation. So here, with the map reduce function, I make the average by hand. So I calculate for all the observation the average of the moose, and the average is for all my observation, the average is 9.7. No, it's not that like column you won't have with you won't have because I'm not in the same environment. So I think you don't have a software which can display sorry. So okay, we will pass those requests. If there are problems, we are going to gain the most interesting one. Is the geoqueries. So here you have queries that First one is there. We find all the data near to a point. I take the point randomly, so I can know the results. So here, what do I do? I try to find all the observations which are near to a point defined with a max distance of 10 meters. Okay, so here I put a point and okay, use Johnny, and we will use Johnny. So Johnny will give you almost the same result, but display differently. It works, Johnny? No, I had the two versions without Johnny, with near, which is the old ways to do that. And here, the second one, which makes the same thing in with the distance converted in radius. The reason why I made this computation the 10 meters converted in radius, and it does the same thing. Okay, to find documents inside a polygon, you have GeoWithin. So there are two versions of GeoWithin. Donc you define a square. You define a square and you find query. I must have taken a wrong, yeah. We are going to do it graphically just after. So, okay, if you want to find something within a form, you type GeoWithin command. There's $polygon to define polygon, and you put the coordinates. So I put them randomly, so I miss them. Maybe I'm in the C. And the geonear distance, if you want to aggregate total amount of sable near to the point, I wanted to show you that one because it's an aggregation, it's a complex request, and it's an interesting request. That's there is no sub point, but how does it work? First, he makes a geonear. It selects the distance. Right? Okay. Okay. Okay, now how does it work? An aggregation is a stream of requests. First, I make a selection request of points near another point with a distance. Okay? And then, with the results of this request, I make a second request, which is a group according to no property of the property sub, and I must just only have one, and the result is the amount of sand is 16. I don't know how much I have, I can make a count, but I have 6. The amount of sand is 60. Okay. So first, I retrieve only the points which are near something, and then I'm making the operation plus. So this is a little tricky way to put request, because console mode is not a sexy mode, and I would like to show you with a good, nice interface how can it be used and what's the render of that. So you connect with Chrome. You launch Chrome, excuse me. La base elle est lancée. Après je suis lancé. And you type the following address. Ah oui, non, mais ici c'est normal. Je take. Okay, try this at home. Only I didn't make the. So it's localhost /georef. Then you will be connected to the database and to a map. So you basically, I present you Po. Is the center of Po, and we've got some data. If you click, here is the map of Po, our town. Okay. If you want to see data in relation of Po, you have some data and the little icon on the right. There is a little icon where you can choose a raster and some data. If you check the bus, by example, you will see the line of bus of the city of Po. If you click on bars, you will see the bars of Po. If you click on a pointer, you will have information of this pointer. You can type it because I didn't put it on the computer. I put it on that computer. Yeah, on that one. I will give it to you.
Okay.
Okay, so basically you have this, which is Po. And then here you can change the background of the map. You have the classic Google, you have Google Stats, and OpenStreetMap, which is free rasters. Then we are going to check what's happening on Spitsberg. So Spitsberg, if you want to see where it is, you have to click on the plan tools. And you see the plan tools appear right next to the North Pole. So you dezoom, and if you want to dezoom, you have to be in a Google raster. And then there is a little lag because we are asking the same thing at the same time. And you see all the observations. It's cloudy in Spitsbergen. So the Google raster are maybe if I choose OpenStreetMap it will be no. So here you have the observation. If you click one, you have the detail of the observation. But I don't have any. I wanted to load some data from Hanoi, but I didn't have didn't have data about Hanoi. So my data are only on Po and on Spitsbergen. Right, we have all the data in the database, the MongoDB database, and when we request of all the data, and we have displayed it using JavaScript and the framework of geo representing GeoSpace. And we can try some. So if we click on a point, I've displayed all the relevant informations, which are not new informations. So you can click on a point and have the information. It's all the information we have on the database for this observation. Okay, and we can make queries. For example, if you click, I don't see it anymore, but if you click on the rectangle, draw a rectangle. Draw a rectangle, I will try. A rectangle. If I draw a rectangle here, I'm sorry. It's not the database. It's not the database, it's the network, I think. We are all asking for maps at the same time, and the Google API and OpenStreetMap. You have got a small cable, so there is a traffic jam on the cable. Non? Personne ne vote? Huh? It should have been impressive, but sorry, it's, the network. But you have it. So you can draw special requests like I draw a rectangle here, and then I click on the rectangle and I say give me all the information which are on the rectangle. Okay? You got all the information on the rectangle. Okay. And then I can put a point here and say give me all the information at a distance of 500 meters, for example. Okay. And then I got all the data. Maybe because move this point to the center. Well, we want to retrieve the network
Après, je ne peux pas comprendre quand
all the data and it's not here, it's not correct. So you have to do zoom, it's a problem, and they are on the side. Okay, so we'll end with a flash.
Si toi tu as déjà normally you have possibility to have a geographical query. You can go try and answer on Torus for request. See when directly Horizon and directly
Here is the file. If I check
c'est une perceptuelle là qui répondra à la
So when I load register, I load it from URL. Doing queries, there are queries that are faster than the SQL. We would run a find or find, for example, which is near, it's less fast, it's slower than aggregate. For example, aggregate is very fast. Reduce so transform it into aggregation or into reduce. Much more. The advantage of that is that it provides JSON, which when you are doing web app, query and yes. So I stopped there. I wanted to show you something impressive, but So will be next workshop maybe. So I end it there. Thank you very much.